Okay, now we're going to be doing the letter E. The third one I'm going to do, and the last one you're going to do the other four by yourself: B, D, F, and G. But the one thing is, if something like C2H6 is given, then I have to give you what it is, or it has to be available on your reference table, or you'll have to be able to determine it by the rules that we've done in Unit 4 and Unit 5 when we studied those. It might say something about sulfuric acid. That's something you're supposed to know. It's H2SO4. But since it's not given and it's not on your reference table, I have to give that to you. C2H6 is ethane. So you're going to try and do the same exact process you did for A and B and C with this one. This one's a little bit harder to balance, but we'll get there in a second. But first of all, you can come up with a word problem. Since I gave you what ethane is, all you have to put down is ethane. Ethane reacts with oxygen gas to produce carbon dioxide and water. Very simple word problem. Once again, ethane reacts with oxygen gas to produce carbon dioxide and water. Simple. Then you go to what type of chemical reaction is this? What type of chemical reaction? Oop, I forgot to put that down. Let me put this down somewhere. Type of reaction. What type of chemical reaction is this? Do a better color than that. Yellow is always bright. What type of chemical reaction? Okay, so you have once again, it's not as small plus small as a big. It's not a big breaking up too small. Here we go with that combustion again. A hydrocarbon, C2H6 is a hydrocarbon, which means it's a molecule that only has carbon and hydrogen as part of it. Reacts with oxygen gas to produce carbon dioxide and water. That's what a combustion is. That's what I gave to you yesterday, and that is also on your page number 6 of your reference table underneath the solubility rules. So this is a combustion type of reaction. Let's keep going. Now you have to balance it. This is a little bit more difficult to balance, but we'll do that. I already have the balanced chemical equation for you. 2 ethanes react with 7 molecules of oxygen gas, to produce 4 molecules of carbon dioxide and 6 molecules of H2O. Let's see how we can balance this. Okay, now I went ahead and took the liberty to put the skeleton formula down. C2H6 plus O2 yields CO2 plus H2O. These are how many atoms of each type of element are on there to start off with. On the left side, on the reactant side, you have 2 carbons starting off, you have 6 hydrogens starting off, and you have 2 oxygens starting off. That's what you have to start off with. Remember, at the end, all of these have to equal. Now, starting off with, well, remember the first thing you do, I forgot to tell you, is to put that line perpendicular to the yield sign. Then you go ahead and list the amount of elements of each number of atoms of each element you have on the right-hand side. Here you have 1 carbon, you have 2 hydrogens, and you have 3 oxygen. Make sure you have these in the same order. Also, it's suggested to always put oxygen last, hydrogen second to last, unless everything else above it. But you don't have to always do that. But here you have carbon, hydrogen, oxygen in the same order. Now you got to say, well, look, carbon's not balanced. So let's go ahead and try a 2 here. You put a 2 in front of the carbons, that balances the carbons, 2. But it changed the number of oxygens. So now you have 4 plus 1, because we had 3. Now you have 2 times 2 is 4 plus 1. Now you have 5 oxygens on there, right? So now you say, well, I have 2 carbons, very good. We have 4, 5, and so we need to put, what can I multiply 2.5 by in order to, let's see, we have 4, 5, 2, 6. Oh, I have to put a 3 there. Yes, so we have the hydrogen. You have the carbons are balanced, 2, 2. I was trying to go to the oxygens first, because I know those are the ones we have a problem with. But you've got to balance the hydrogens first. You have 6 there, 2 here. Easiest way is to put a 3 in front of their coefficient and giving you 3 molecules of water. That changed the hydrogen instead of a 2 to a 6. 3 times 2 is 6. That also changed the number of oxygens. Now you have 2 times 2 is 4, plus the number 3 is 7. This is what I was trying to do a second ago. So now you have, look at it, you start from the top again. The carbons are balanced, 2 to 2. Hydrogen are balanced, 6 to 6. The oxygens are not balanced, 2 to 7. Oh no, so the easiest way to do that, What can you multiply that by in order to get a 7? You can multiply that by a 3.5. So in other words, put a 3.5 up here. But when you say you can't have a half a molecule, that is correct. So what I told you in class, we did one or two of these in class before. This would have a 1. So you multiply everything by 2. This was starting off as a 1. Remember, there's nothing written. I told you it's always good to put the 1. You don't have to, but I wish you would. So now you multiply it by 2 to get everything to be an even number. 1 times 2 is 2. Then you take the 3.5. Multiply that by 2 is 7. And you have to multiply everything by the 2. That 2 becomes 2 times 2 or 4. And that 3 times 2 becomes a 6. There's the balanced chemical equation for that. 2746. 2746, right? Okay, so let's keep on going. Answer some questions now that we have it balanced. Remember, you have to balance that in order to do any other, answer any of the other questions. Equilibrium chemical equation. Once again, you put the products above the bar, bracket CO2, close bracket, but you have 4 of those. A coefficient of, the coefficient of 4, that goes as your superscript. Then you have open bracket, H2O, close bracket, but you have 6 waters. So therefore, as a superscript, you put a 6. Notice again, there's no plus sign there. You've got your products done. You go back to your reactants. You have ethane, C2H6, put brackets, C2H6, close brackets. You have 2 of those, exponent of 2, open bracket, O2, close bracket. But you have 7 oxygen gases, so that goes as a superscript of 7. So there is the equilibrium chemical equation for this chemical reaction. And once again, always if you're doing a doing a equilibrium equation, those arrows should go in both directions. In other words, if it can produce in that direction or it can produce in that direction. Okay. Now we can answer some more questions. Now the balance is already there for you. So what are the reactants? The reactants are things that reacted ethane and oxygen gas. And what are the products? The products were carbon dioxide and water. The numbers in front are called coefficients. How many atoms of each of the elements, carbon, hydrogen, oxygen, were present on both sides? They have to be the same. You have 4 carbons on the left, 4 on the right, 12 oxygens on the left, 12 on the right, and 14 oxygens on the left, 14 on the right. How many molecules? You had 2 ethane, you had 7 oxygen gas, you had 4 carbon dioxide, and you have 6 waters. Hopefully we got that. Now you have to do those other 4 by yourself. Now pay attention. A lab exercise day 1. You also have to watch this video today. It's like a 14-minute video or something. I'm not sure how long it is. But it's going through details and tells you the materials and everything else. It's not written down for you. So be sure and take the time. Watch that video. Sometimes maybe watch it 2 or 3 times or stop it so you can write the things down. And it's going to tell you all the things you need to do for the day 1 of the lab. I'm actually going to have a 3-day drying session. Now, this video for the lab was actually videotaped on Saturday. I think I did that part on Saturday, but it doesn't matter. But for your sake, it's happening right now. But watch this video. Make sure you take good notes because tomorrow you're going to have to write, Wednesday, you're going to have to write the lab report out, and you need to use the same template that we've always done in class. Use the same template. And make sure you recognize this is lab number 9, and the word buttons have to be in there. And what your purpose is, you're trying to, I can make buttons by mixing vinegar and milk or something like that. That's what you're trying to do. And you'll be able to see the button that I made. I made 1 button there for you, okay? Well, thank you. And I hope you enjoy the lessons today. I hope everyone got the message that I'm not going to have you submit anything for class until starting on Wednesday. Wednesday, you'll be required to start submitting everything to Google Classroom. I'll give you some more information on that tomorrow. That's going to also count as your daily check-in. That way I know you're doing what you're supposed to do, and I know that you are on the receiving end of what I'm giving you. So hopefully you're paying attention because one of these days, we never know, the state test could still be given to you. So make sure you recognize that we need to be prepared to do what we're supposed to do. Actually, stoichiometry is only one more step. It has a couple of equations to do on it, but it's really just one more step from what we've already done. So if you can do what you're doing right now, and we'll be working on these 3 or 4 more days, and you'll get tired of them, just like we did in class. But if you can do this and get proficient on what we're doing right now, then stoichiometry is only maybe 1 or 2 steps at the most up. So if you feel comfortable in this, that's great. And give yourself a few more days if you're a little bit sketchy on it, because you will get some more time to get more proficient on it. Anyway, thank you. Y'all stay safe and be happy. Okay, take care.